Hi guys, so in this video we are going to discuss about electrostatics. So as the name suggests, electrostatics, electro in the sense nothing but electrons, static in the sense at rest. So here uh, the studying of a behavior of electrons at rest is called electrostatics. Very simple, right? So here, if you take any matter lo unde fundamental particles enti electrons, protons, neutrons. So మనకి తెలుసు electrons are negatively charged and protons are positively charged. Coming to the neutrons, they have no charge on them, right? These are the words we used to learn from chemistry, physics, now and then. So here, first of all, we have to know what is charge. మనకు అసలు ఛార్జ్ అంటే ఏంటో తెలియాలి. దెన్ యూ కెన్ అండర్స్టాండ్ ద లెసన్ వెరీ ఈజీలీ, రైట్? సో ఈ వర్డ్ మనం ఎక్కడ యూజ్ చేస్తామంటే పోలీసుల దగ్గరికి వింటూ ఉంటాం, లాఠీ చార్జ్ చేయండి అంటాం. సో వాట్ ఈస్ ద మీనింగ్ ఆఫ్ లాఠీ చార్జ్? Applying certain amount of force by using lathi, that is called nothing but lathi charge, isn't it? So here, why the particles have charge? The particle which has charge is called charged particle. So charged particle అని ఎందుకు పిలుస్తామంటే, whenever the particle surrounded by the some other similar particle, then it can able to apply some electric force or magnetic force, right? So such kind of property is called charge. Not only applying the electric and magnetic effects, it can also experience the similar kind of forces from the other charged particles. So this nature is called charge. So మన నేచర్ లో న్యాచురల్ గా మనకి ఉండేవి టూ చార్జెస్, ఒకటి వచ్చేసి పాజిటివ్ చార్జ్ అండ్ అనదర్ వన్ వచ్చేసి నెగిటివ్ చార్జ్. సో ఈ పాజిటివ్ చార్జెస్ ఎప్పుడైతే, ఐ మీన్ నాట్ ఓన్లీ పాజిటివ్ చార్జెస్, negative charges also, right? When the like charges come closer, they repel each other because of the property charge, right? So whenever the object is charged, I mean charge is the property associated with matter. So you can never find charge freely. You can't find charge freely. It always associated with matter. Matter can exist without charge, but charge cannot exist without matter. It always associates with the charge. So we'll learn that also, right? So if you observe here, unlike charges, what they do, they attract each other, right? So coming to the properties of charges. Before starting properties of charges, let's see the units of charges, right? So coming to units of charge, uh, nothing but coulombs is the unit of charge. Coulomb is the unit of charge. At the same time, from this formula, I is equals to nothing but dq by dt. By using this formula, you can have the ampere per second, that is equals to unit of charge. This is the SI unit of charge, ampere second, or else we can use coulomb on the renowned scientist Coulomb, right? So at the same time, coming to the CGS units, ESU, very important. I mean, many of don't know that ESU. This is the CGS unit of charge. Means electrostatic unit. This is the CGS unit of charge, and we can convert it if you want, right? So coming to the properties of charges. ఒకసారి properties of charges చూస్తే కనుక, properties of charges చూస్తే కనుక, quantization of charge. The first property is quantization of charge. Many properties are there. So let's see one by one clearly, right? So quantization of the charge. Here, in the nature, the charge always available in the multiples of electric charge. That means in the nature, the least amount of charge that we get is 1.6 into 10 to the power, yeah, here it is, 1.6 into 10 to the power of minus 19 coulombs. This is the least charge that we get in this universe. No matter, you can't get than this least, right? So here, for example, you have certain amount of charge with you. So that charge definitely multiples of this number, no doubt. For example, an object has q amount of charge on it. So what does it mean? That q amount of charge is nothing but multiple of 1.6 into 10 to the power of minus 19 coulombs. This property is called nothing but quantization of a charge, right? So charge of an electron, this is nothing but if you take minus here, it will become the charge of electron. If you keep plus instead of minus, if you keep plus, then it becomes the uh, charge of proton. Clear, right? So here positive, I mean proton and electron both are having the same amount of charge, just a symbol is a difference. Plus if it is minus, then it is a charge of electron. If it is plus, then it is a charge of proton. Clear. So and coming to the next one is additivity of charge. Coming to the additivity of charge, so if you observe, the second property of the charge is additivity of the charge. Additivity in the sense adding, right? Q net, the total net is equals to nothing but algebraic sum of all the charges of the system, right? If you take any system, in that system there is a certain amount of charge, right? Plus q1 plus minus q2 and plus q3. So now here the total charge on in this system, on the system is nothing but q is equals to q net is equals to plus q1 minus q2 plus q3. Adding sign conventions is very important, okay na? So the algebraic sum in the sense nothing but you have to add them with their sign, right? A plus into plus, minus into minus add చేయడం. దీన్ని మనం ఏమంటామంటే additivity of the charge. The charge can be added or can be subtract also, both can, right? So whereas coming to the third one, so if you observe, coming to the third one, where it is, yeah, here it is. Now coming to the third property of the matter is, I mean third property of the charge is conservation of charge. It's very important. So conservation of charge in the sense nothing but the total charge of an isolated system is always conserved, right? So charge neither be created nor be destroyed. At the same time, when a single charge and a negative charge formed, along with that, the same amount of positive charge also will be formed in the pair. Okay, na? So when the single charge destroy, that means along with the negative charge, positive charge also will be destroyed. I mean that means they both become combined, right? సో ఒక సింగిల్ ఛార్జ్ ఫామ్ అవడం అనేది జరగదు నేచర్లో. ఇది కూడా చాలా ఇంపార్టెంట్, రైట్? సో అంటే ఫర్ ఎగ్జాంపుల్ ఒక ఆటం ఉంది, ఎలక్ట్రాన్ బయట తీసాం, ఎలక్ట్రాన్ బికమ్ ఐ మీన్ నెగిటివ్ ఛార్జ్, రైట్? సో సిమిలర్ ద ఆటం బికమ్స్ పాజిటివ్లీ ఛార్జ్డ్. ఎంత ఛార్జ్ అయితే రిమూవ్ చేసామో అంత పాజిటివ్ ఛార్జ్ పెరుగుతుంది, రైట్? సో ఇట్ ఆల్వేస్ ఇన్ ద పేర్, ఖచ్చితంగా, ఓకేనా? సో దిస్ ఇస్ అబౌట్ ద వన్. అండ్ వన్ మోర్ ఇంపార్టెంట్ ప్రాపర్టీ ఈస్ when the electron is at rest, it produces only electric field. When the same electron is in the motion, uniform motion, or else unaccelerated motion, then it produces electric field and magnetic field. But if the particle will be, I mean particle is electron will be in accelerated motion, then it produces electric field, magnetic field. Along with them, it radiates some energy in the form of electromagnetic wave. Very important point for JEE advanced, right? So we are discussing very clearly, right? And coming to the yeah, conservation of charge is completed. Now coming to the uh, charging of bodies. Coming to the charging of bodies, so charging of body, how to charge a body, right? The first method is charging by rubbing. Charging by rubbing, or we can call it as a friction method also, we can call it as a friction method. So just you take a simple example, let me tell, right? You take the glass rod and a silk cloth and rub the glass rod with the silk cloth. Then what happens? Some electrons will transfer from the glass rod to silk cloth, right? So here, then what happens? The glass rod becomes positively charged, right? Because the electrons from the before the glass rod is neutral, but neutral object, right? It doesn't have any charge. And the silk cloth also, when they both rubbed each other, then what happened? From the glass rod, the electrons transferred to the silk cloth. Because of that, the glass rod became positively charged, right? So the silk cloth became negatively charged. How much charge that will be get by the positive, I mean glass rod, the same amount of charge will be get by the silk cloth. But here, if the glass rod become positively charged, then silk cloth become it becomes negatively charged, right? But the amount of charge will be same on the both objects, no matter, no matter, the charge on the both objects will be same, right? But oppositely they charge. So here you should get doubt, why should glass rod only will lose the electrons, and why should a silk cloth only will gain the electrons, right? So here for that you must know about the work function. Here the work function of the glass rod is very less than that of the silk cloth. Work function is nothing but from the atoms of glass rod, from the atoms of glass rod, valence electrons, you know, right? Every atom will have valence electrons, right? You can easily the energy required to remove the valence electron from the atoms of glass rod is very less than that of the silk cloth. సో కాబట్టి సిల్క్ క్లాత్ లోంచి ఎలక్ట్రాన్స్ మనం బ్యాలెన్స్ ఎలక్ట్రాన్స్ తీయడానికి ఎంత ఎనర్జీ అయితే యూజ్ చేయాలో దానికంటే తక్కువ ఎనర్జీతో గ్లాస్ రాడ్ ఆటమ్స్ లో ఉన్న బ్యాలెన్స్ ఎలక్ట్రాన్స్ మనం ఈజీగా రిమూవ్ చేసేయచ్చు. సో కాబట్టి ఇక్కడ గ్లాస్ రాడ్ అనే వెన్ దీస్ టూ ఆబ్జెక్ట్స్ ఆర్ రబ్డ్ ఈచ్ అదర్, the glass rod will lose the electrons easily. Because of this, the electrons will transfer to the silk cloth. So then the rod becomes positively charged because it has lost electrons. Then it becomes positively charged, right? And whereas coming to the silk cloth, it has gained electrons, so it becomes negatively charged. And one more important point is, yeah, very very important point, right? So mass slightly increases due to the shifting of electrons. When the electrons shifted from one object to another object because of friction, not only because of friction, so whatever the method it is, the mass of the object slightly changes. So here the mass of the glass rod decreases. The mass of the gas rod decreases because it lost electrons. N number of particles it has lost. So n times of electron, its mass decreases. At the same time, the mass of the silk cloth gets increased because it gained the electrons. Clear? So because of the charging process, the mass of the particles slightly change. I mean, the mass of the object slightly changes. Clear? So coming to the charging, we have learned now charging by the friction, or also we can call it as a charging by, where it is, yeah, here it is. Yeah, coming to the next property, the next I mean next method for the charging object, it is nothing but charging by friction, right? Charging by friction. So coming to charging by friction, sorry, charging by friction complete అయిపోయింది కదా. Yeah. Charging by touching the body, we can call it as a conduction. uh, the first method is friction and the second method is conduction method, right? Charging by touching, or we can call it as a conduction. So here if you observe, we have taken a positively charged body. ikkadunna ee positive, what about the glass rod? It became positively charged, right? When it is rubbed with silk cloth, it became positively charged. So ఈ glass rod ని తీసుకుని let takes to the metal sphere, మెటల్ స్పియర్ దగ్గర తీసుకొద్దాం. సో అండ్ దిస్ మెటల్ స్పియర్ ఈజ్ ఆన్ ద ఇన్సులేటింగ్ స్టాండ్. This metal sphere is on the insulating stand. Clear? So because of this, the charge cannot travel to earth. Clear? When the metal sphere is on the insulating stand, the charge cannot travel through insulator, right? This is about the insulating stand. And here we have taken this glass rod and this positively charged glass rod, and we made it touch with the metal sphere. అంటే దాని గ్లాస్ రాడ్ ని మెటల్ స్పియర్ దగ్గర తీసుకొని దానికి టచ్ చేపిస్తాం. సో వెన్ ఇట్ ఈస్ టచ్ టు ద మెటల్ స్పియర్, దెన్ ద ఎలక్ట్రాన్స్ విల్ ట్రాన్స్ఫర్ టు ద గ్లాస్ రాడ్. Immediately what happens, the electrons will sorry, yeah, the electrons will transfer from the metal sphere to glass rod. Because of this, this glass rod become neutral, I mean neutral in the sense, if n number of particles, I mean for example, only q small charge, if q charge is traveled from here to here, then the rod charge becomes nothing but q minus capital Q minus small q. ఓకే. సో అలా కాకుండా ఒకవేళ ఎంత పాజిటివ్ ఛార్జ్ అయితే ఉందో అంత నెగిటివ్ ఛార్జ్ ట్రాన్స్ఫర్ అయిపోతే దెన్ వాట్ హ్యాపెన్స్, ద గ్లాస్ రాడ్ బికమ్ neutral, right? So but then what happens when the electrons transfer to the glass rod, then the sphere become positively charged, right? Because the sphere has lost some electrons, right? Some electrons transferred to the glass rod, so because of this it becomes positively charged body, right? And this charge spread over the surface uniformly, right? Then it becomes uniformly charged. See, if you touch positively charged body, then metal became positively charged body. And if you touch with a negatively charged body, then metal becomes negatively charged body, right? This positive charge no more will be there, right? So like charge, if you bring whatever the charged material you bring to contact with the metal ball or metal sphere, the sphere also gets the similar kind of charge. This is about the uh, charging by touching. And whereas coming to the second one, coming to the third one, right? Third one is, yeah,